Hey, good morning everyone. My name is Vipin Kumar and I am back with another video how to create ARM template and launch Linux machine. In this video, we are going to learn how to create a ARM template in Visual Studio. Then we are going to add this ARM template in Azure Portal for reusability. And finally, we are going to use ARM template to launch multiple Linux machines. So let's begin. Before writing or using ARM template, it is strongly recommended that you should be completely aware about a manual process for which you are writing a ARM template. For example, in this demonstration, we are going to launch multiple Linux machines with help of ARM template. So, you should be aware about a complete manual process how to create and launch Linux machine manually in Azure Portal. If you understand complete manual process of creating and launching Linux machine in Azure Portal, you are ready to write ARM template. You can download the sample ARM template for Linux machine from my GitHub account. Go ahead, download and open this template in Visual Studio. I have already downloaded and opened this template in Visual Studio. I am using the Visual Studio Community Edition, a freeware version of Visual Studio. You can download a Community Edition without paying any license. You can write the JSON template in any text editor or any IDE, but I feel more comfortable in Visual Studio Community Edition. So this is the sample template for creating and launching the Linux machine, and this template has four major components. You can see in the left hand side, one is parameters, second is variables, third one is resource, and fourth one is outputs. In this template I am using 8 parameters. So basically the parameters are used in this template to accepting the user input for the templates like admin username of virtual machine, admin password of the virtual machine, virtual machine name, and I'm using 12 variables for the ARM template, and then I'm using 6 Azure resources to complete ARM template like virtual machine, storage, network security groups, etc. And finally, in the output section, the hostname and SSH command going to be generated or printed after completion of this ARM template. So let's go ahead and look at this template line by line. Line number 2 is schema location for the JSON template or format. Line number 3 is a version control system of this ARM template. From line number 4, the parameters section start. It means that we are going to accept the input from the users. First one is admin username. So this is the username for the virtual machine, admin password, and type is secure string. It means that when you are typing the password in the text box, it is secure string. You will not able to see the content of the password box. DNS Label Prefix. So you can see in the description, it is a unique DNS name for the public IP used to access the virtual machine. For example, you can assign the DNS name like web01, web02, db01, db02, and this DNS name is going to assign to public IP address, and after that you can use this DNS name to access your Linux machine. Like you can use db1.xyz.com to refer your database server 1 and so on. Then Ubuntu OS version. It is going to offer you to select Ubuntu OS version on the template. These are allowed values, and if you don't select any of these value, the default value 16.04.0 is going to select automatically. VM name. You are required to supply the virtual machine name, and after that you required to provide NIC name, nickname for the virtual network. The public IP address name, you require to provide the name of the public IP address. Line number 54, location. You don't require to provide the location in the ARM template. It is going to select the location automatically for your resource group by using resource group dot location. Next section start for the variables. First one is storage account name. Azure offering two kind of the disk. One is managed disk and second is unmanaged disk. And in this template I am using unmanaged disk, and for that you require to create a storage account for the unmanaged disk. Storage account name should be unique. For that I am using the concat function to merge two values. So I am getting a unique string from resource group.id and adding with SA Linux VM to create a unique storage account name. Then I am creating a image publisher variable canonical, and it is required while you are creating a Linux VM. Then I am creating another variable image offer Ubuntu server. It is required while you are creating a Linux VM. Then address prefix with 10.series. This CIDR required while we are creating virtual network. So let me explain the workflow of the network while we are creating and launching the Linux machine. First of all, we require to create a virtual network with address prefix or CIDR, and allowed IP range is 10.0.0.0 series. Second one is 172.0.0.0, and last one is 192.0.0.0. And after that you require to create a subnet under the virtual network, and you require to provide a subnet prefix in the same range of address prefix. Then you require a public IP address to access your VM, and public IP address can be dynamic or static. In this demonstration I am using a dynamic public IP address, but it is always recommended use a static IP address. And finally you require to create or attach network security group NSG on the allowed protocol. Once your network is created according your requirement, then you launch a Linux machine under this network. Then a NIC interface attached to this network, and VM will get a private IP address from subnet prefix address. So this is the complete network workflow, and our ARM template is based on this network workflow. So we are using the address prefix for the virtual network under the 10 dot series. We are assigning the subnet name. This is the subnet prefix, and this is the storage account type. We are using the standard Azure offers standard or premium storage, but for the demonstration, I'm using a standard one. Public IP address, I'm using a dynamic, and I'm creating a NSG rule with name of client, and I'm creating a virtual network name with name my VNet. This is the subnet reference, and I'm creating a subnet reference with service provider and virtual name and subnet. Next section is start resources, and in this section we are actually creating the resource that is required to create and launch Linux machine. First one is a type. Type is nothing but a service provider or resource provider, and I'm using the resource provider is Microsoft.storage, one of the service called storage account. This is the characteristics. We required a name, and name should be unique, and this storage name coming from the variables. This is the API version, that's fine. The location is coming from parameters location option. SQ is a nothing but is a stock keeping unit. You can understand SQ like you are going for shopping, and you look at a item. When you are go for a billing for the particular item, then seller scan the tag to get a record of this particular item from their inventory, the product name, product size, product color, product number, etc. So this SQ function required couple of the variables or characteristics. One is storage account type. So in this demonstration, I'm using the standard LRS. Kind is storage and property is blank. Next one, we are going to use Microsoft.network, a resource provider, and under this resource provider we are using public IP address to create a public IP address for the virtual network. The parameters is a public IP address name that is coming from user input, location coming from automatically from the resource group. These are properties that is going to attach or assign for the public IP address. What is the public IP allocation method? Is a dynamic or statics. I'm using a dynamic. So this public IP address has the property of public IP allocation method is dynamic, and DNS setting will be DNS label prefix parameters from user input. So next one is virtual network. We are again using the resource provider network, Microsoft.network, and creating a virtual network. We are creating the virtual network with the virtual network name that is coming from variables, the location coming from resource group. This virtual network has multiple properties like address space. We require to provide a address prefix, and this address prefix is coming from variables 10.series. Then virtual network required to assign a subnet, so it is coming in this property sections. We require to provide a subnet name that is coming from the variables, and subnet has a properties that is called address prefix, which is coming from the variables. So once the virtual network created with the provided value under the properties sections, next one is network security groups. Again, we are using the Microsoft.network for network security groups creation. The name is coming from the variable of client, location coming from resource group. Tag, we are assigning a tag to this security group called front end, and these are properties. In this properties section, we are creating a security rules, and each security rules has its own properties. First security rules we are creating for SSH, and this security rules has these properties. First one is description, allow SSH protocol TCP source port range any, destination port range 22, source address prefix internet, it means any, destination address prefix any, allow access priorities 100, direction inbound. Basically we are providing all the values that is required to create a security rules for the network. Second security rules we are creating called web rule, and these are properties, and in this security rules we are creating the security rules for port 80. Next one is very important, and this is going to create a network interface in the virtual network and attach to the virtual machine. Again, I'm using the Microsoft.network to create a network interface. This is the name, and name is coming from the parameters, location coming from resource group. Now look at on my screen depends on, and look at the definition that is coming from Visual Studio. Depends on collection of the resource. This resource depends on type array. It means that network interface is not going to create until unless these three resources successfully created. First one is a public IP address, second one is virtual network, and third one is a security groups. And these are properties of the network interface. First one is IP configuration, and you can see a definition, a list of IP configuration or IP of the network interface. It has the property, the private IP allocation method is a dynamic, a public IP address going to attach with this network interface, and this public IP address is generating from this ID. Next property is subnet. A private IP is going to create and allocate to this network interface from this subnet reference. Next property is a network security group. This particular network security group ID is going to attach to this network interface. Once all other resources are ready to use, finally we are going to attach all the resource into the virtual machine resource group. I'm using the resource provider is a compute to create a virtual machines, and this is the name, and virtual machine name is coming from the parameters, location coming from the resource group, and it depends on storage account and network interface. It means that virtual machine will not initiated or created until unless these two resources are successfully created. It has flowing properties. First one is a hardware profile, and we are requesting a particular VM size in a variables. VM size is standard A1. Next one is a OS profile. We are getting the computer name from the parameters, admin username from the parameters, admin password from the parameters. Next one is a storage profile, and it required some of the values to create a storage, like who is your publisher, and it is coming from image publisher variables. We can see image publisher variable here. It is a canonical. Next one is a offer, and it is coming from image offer variable SKU stock keeper unit. It is coming from parameters Ubuntu OS version, and version is latest. Next one is OS disk. It is a operating system disk, and it is creating from the image. This is the image variables. It means that while Ubuntu machine is booting up, it is going to create a system disk along with a temporary disk on the Ubuntu machine. Next one is a data disk. This is the operating disk for the OS related files and folders. And second one, we are creating a data disk for the application data or user defined data. And you can define a size of disk. You can define a logical unit number for the data disk with creation option empty. Next one is a network profile for the network interface, and this particular network interface ID is going to attach to the OS, and ID is Microsoft.network network interface and parameters is nickname. And diagnostic profile is optional. This option enables to write down all bootable issue logs into the storage account. And finally is a output section. Once this ARM template successfully completed or executed, will get two output. One is hostname, second is SSH command. It will print public IP address and DNS name of the Linux machine. In the SSH command, it will print the public IP address and DNS name to connect Linux machine. Once you are comfortable with this template, then you can add this template into the Azure portal for the reusability. To start the Azure automation, you require to create a Azure automation account in your subscription. I am on the Azure portal console, and in the services you can search automation. Select automation account. Let's create a automation account. Automation features or service is not available in all across location. So select the location that is nearest or cheapest for your account. Create Azure Run Hedge account. Click on yes. It is equivalent when you are running any program or service as a administrator. Click on create. This user account is going to use not only for ARM templates, for other services also like DSC. The automation account has been created. Now let's create a template for creation and launching VM. Click on template services. These template is already added in my account. Click on add. Give the name of the template. Once you complete name and description, click on OK. Now add ARM templates. Copy and paste in ARM location. We are good. Click on OK. It is validating your ARM template. If validation goes fine, then click on add. It is saving your template in this location. Go for refresh. ARM template Linux has been created. Let's go ahead and deploy this template or create and launch Linux machine. You are getting the option deploy. Click on deploy. We are ready to create and launch a Linux machine. Let's submit the parameters or input for the Linux machine. Select the resource group, username of VM, password, DNS label prefix, VM name, NIC name, NIC interface name, public IP address name. Click on agreement, click on purchase. It is validating all your input. Once the validation is completed, deployment in the process. We can see the progress. Deployment has been completed. Let's verify. Click on virtual machines. The virtual machine has been created. Let's look at the property of the machine. We got a public IP address. We got the computer name. Look at the networking. We got the private IP from our CIDR blocks. We got two security tools on port 22 and port 80. We got two disks, one for OS disk and second for data disk with our size. So let's try to log in on this machine. Before creating another Linux machine from the template, I am using putty. Say yes, security warning. Login on this machine with username and password which you supply in the ARM template during creation of VM. Now you can see here we can successfully log in our newly created Linux machine via ARM template. Let's go ahead and create another machine from ARM template to test reusability. Let's log off from this machine. Go back again in the template area. Select the ARM template Linux. Click once again on deploy. Submit all required parameters for the Linux machine. Let's go ahead and click on purchase. It is validating again your parameters and input. Once validation went successful, it is going to create a second VM for you. You can always see the progress of the deployment. Deployment has been completed. Let's look at the output of this template. As we discussed in earlier, this is the outcome of the template, the host name of the virtual machine, and this is the SSH command. So let's try to log in on our server with this output. This is my user account. Well done. We successfully able to connect our second Linux VM with DNS name. Now you can understand how it is easy to launch multiple VMs by using the ARM. You can use this ARM template as a standard practice. I hope you enjoy and learn in this video. That's all in this video. Thanks for watching. Bye.